Hello. AI Crystallographer provides tools for deep and machine learning-based analysis of atom-resolved experimental data. Currently, it offers the following tools. AtomNet, which applies a fully convolutional neural network for locating atoms in noisy experimental microscopic data. DefectNet, which allows locating atomic defects, meaning defects that break atomic lattice periodicity in atom-resolved movies with a fully convolutional neural network using only a few movie frames to generate a training set and train a model. FerroNet, which applies different machine learning and multivariate analysis techniques for analysis of ferroic distortions in electron microscopy data from ferroelectric and ferroelastic materials. And SymmetryNet, which uses a deep convolutional neural network to determine 2D Bravais lattice symmetry from atomically resolved images. AI Crystallographer is a Jupyter notebook-centric project, and the easiest way to work with it is by opening notebooks in Google Colab. Now, there are three ways that you can open a GitHub notebook in Google Colab. First, if a notebook has an Open in Colab icon at the top, then you just click on it, and it will open a notebook in Google Collaboratory. The second option is to install a browser extension that would allow you to open any notebook hosted on GitHub just in one click, just like that. And finally, the third option is to go to Google Colab start page and then type in microscopy / AI Crystallographer. And you will get a list of all the notebooks in AI Crystallographer which you can open. Now let me demonstrate how these notebooks work using an example, using as an example an Atom Finder notebook from AtomNet. So let's open it. Now, when you open a notebook in Google Colab, it creates a free virtual machine instance on the Google Cloud platform with all major deep and machine learning libraries pre-installed. So you do not need to install anything yourself, just open notebook and run it. So we'll start here by uploading our custom models and saved weights of trained neural networks. And then we import standard and our custom models into this notebook. Now here you specify a file path for your experimental data, and let's actually upload a new experimental data from our local machine. Now let's change a file path. All right, now we loaded this data. Now let's load a trained neural network. So we need to specify a type of system that we have. Currently, we have neural networks that work for graphene-like systems and for cubic systems like perovskites. And now we apply a trained model to the experimental data that we have uploaded. And we extract atomic coordinates. And now we can plot the results. So we have experimental image on the left, in the middle we have a neural network output, and on the right we have the extracted coordinates. And now we need to save the results and download them back to our local machine, because it runs on the cloud, and once our instance gets recycled, all the data will be lost. So always make sure to download it back to your local machine. Or perhaps to your Google Drive, but here we'll download it to our local machine. Alright, so here is an output. And this is how you can run all other notebooks in this repository as well.